textbook is chapter 9, and you know, some of it is new, a lot of it will be review, and we're even going to go back to equations of a line. Lesson 2, we're going to really remind ourselves that was way back in chapter 3 and 4, so we're going to have to review that, but that will be the next lesson. For this lesson, it's pretty simple. We're going to start with, we're talking about scatter plots, okay? And a scatter plot takes place, we have an x-axis and a y-axis, and we have ordered pairs. These are ordered pairs. So right here, we've got a table in temperatures in Celsius and then Fahrenheit from a local weather station, and first it just says graph the ordered pairs. So Celsius is 0, Fahrenheit is 32. Now, see, it goes by 10, so you're going to just have to do the best that you can. 5 is 41. 10 is 50. 15 is 59. 20 is 68. They do a good job of putting them in order. 25 is 77. And 86 for 30. So there you have it. There is our scatter plot. So now it says, is the slope of the line passing through the points positive or negative? Now, if we were to have drawn a line through here, that line definitely goes up and to the right. So that is a positive slope. All right, so when we have that, let's talk about what that means as we slide over to slide number 2. Okay, scatter plots. This is a very unique scatter plot. Not very often does a scatter plot go perfectly in such a nice, pretty line. Most of the time it looks more like these over here. So, a couple things. First of all, when we're doing scatter plots, we need two variables. The two variables in our first example were Celsius and Fahrenheit. Okay, take a look at right here, Old Faithful eruption. So that would be, you know, eruption duration, so how long it erupts, and then I'm not sure what that says right there. Wow, I can't even read it. Not sure, but there's another one. Ice cream sales. So the temperature of the outside and the sales. Those are the two things that they plotted. Okay, so bivariate. The prefix bi stands for 2, and you know that. 2 variables data. That's why you need an ordered pair. You know, an x and a y, if you will. Okay, a scatter plot then shows the relationship between both of those two variables, and sometimes it's a really good relationship. Sometimes it's like this one is definitely a positive, and it's very, very close to a line. So we would refer to that as a linear relationship, and so on and so forth. So here are these two examples. Now this one, there's definitely a correlation, if you will, meaning you know, it looks like the longer the duration lasts, the higher whatever this represents is. Or over here, and this makes sense, ice cream sales, think about yourself, the higher the temperature, the more sales they make. Because, you know, when it's really hot, who doesn't enjoy themselves on ice cream? So there's definitely a correlation there. And it's pretty close to a line. I would even consider that being a pretty linear equation because it's darn close to a line. Okay, so let's look at another one. Let's plot another one. So take a look at the two things that we are going to, now we're going to plot. Now typically this one is your x and this one is your y. Okay, so weeks, so this is going to be weeks. Typically the first one they give you is the x, and then this is weight. And I'm also going to put pounds so I know what units I'm using. Okay, so week 0, so in other words, when the alligator hatched, it was 6 pounds. Gosh, I feel like that's big for an alligator. 9 weeks later, it was 8.6. So at 9 weeks, we've got 8.6. How about right there? You know, you got to do the best that you can. 18 is 10 pounds. So at 18 weeks, we are up to 10 pounds. 27 weeks, we are at 13.6. So I'm going to say about right there. 34 weeks, so just behind that, 15 pounds. Right smack dab between 14 and 16. 43 weeks is at 17.2. And 49 weeks is almost at 20. right there. Okay, so let's look at this. What does that mean? And that makes sense. It makes sense because the older the alligator gets, what happens to his weight? It's increasing. Okay, so we have a couple things we're going to talk about when we plot a scatter plot. Then there's going to be a couple things we reference. Okay, so the first thing we reference, if we go over here on slide number 4, is variable association. In other words, how are the two variables related? Okay, as x increases, y increases. That would be a positive relationship. As x increases, so as we go this way, what happens to the y? It goes down. That's a negative relationship. And then if there is no relationship, because there sometimes will be no real relationship, then there's dots are all over the place, that's going to be no association, no obvious pattern. Okay, and then, so that's variable association, positive, negative, or no association. Now, linear is just meaning, yes, it's pretty close to a line, or no, it's not close to a line. Like this one looks more like a curve. You know, there's definitely a correlation. It's definitely still a positive association, but it's not going to be linear. Whereas this one is closer to a line. We could write an equation for that line, probably. Okay, so linear or nonlinear. So those are the two things. So let's look at this one. Let's talk about that. First of all, there is definitely a positive association. So it's positive. It is very much linear. Now, is it a perfect line? No, it's not a perfect line, but it looks pretty close to a line. You could probably draw a really good line of best fit through a couple of those points or very, very close to the points. So I would say it's linear. And the last thing they're going to ask for, I'm going to ask for, is a sentence telling me and relating my two variables. So, and weeks old, so as weeks increase, the alligator weight increases. And that's what I'm going to ask for you. Okay, so let's do another example of this. Flip the paper over. Right here, you can analyze this. Now, the ones we looked at so far were pretty close, but we might have an outlier. We might have some random point lying out by himself. I mean, the word itself, outlier. It's lying out by itself. You know, there's still pretty much a positive relationship, but there is an outlier, and that's okay. Then there can also be clusters where there's a whole bunch of points together. You just need to reference those. Okay, so let's talk about that. Here is a more realistic scatter plot. I hope you guys can see the points. If not, look at your paper and look at all these. We got a couple points right here. Notice the points are all on the 1, the 2, the 3, the 4, and the 8, because what are we talking about? We're talking about the data for memories in gigabytes and the cost. So you guys are pretty fresh with most of this stuff. The more memory or the more gigabytes you buy in a device, the higher the price is. It's very much that way. Now, this is probably an old example because there's not many devices out there that only has 1 gigabyte. That wouldn't get you very far. But just pretend, just go with the flow, all right? So we got 1 gigabyte, 2 gigabytes, 4 gigabytes, and 8 gigabytes, okay? So variable association. Is there an association? Is it going to be positive, negative, or none? And I'm going to look here. You guys, and you could almost make this without seeing that. I could talk about it and you could write it. There is definitely a positive relationship because as the gigabytes increase, the price increases for the most part. Is there a linear association? Now, this one oftentimes is opinion. I would say, could you draw a line of best fit? Yeah, it's not going to be great, but there is probably a line we could use to represent this relationship. But that one is a gray area. Some people might say yes, some people might say no, and I can't necessarily say one's right or one's wrong. So I'm going to say that this one is nonlinear. And the reason I'm going to say it's nonlinear because I think there are things like patterns. I think there is a cluster. So clusters at 1, 2, 4, and 8 gigs. Do you see that there's a cluster, 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 cluster? And some might even say an outlier. You might say that would be an outlier. Okay? So those are some things we're going to point out. Let's go down here and look at this one. On slide number 7. Look at that one. Now, variable association, we're talking about a scatter plot for the amount of ice cream sold based on the shape. So what day of the week it is, and how much ice cream is sold, what day. And so they kept track for 20 days how much ice cream was sold. Now, the one on the other side, remember that example that we looked at was the temperature of the day. There was definitely a relationship there. Not necessarily a relationship here. I would say none, because there really isn't one. Linear association, no. There might be an outlier at 2, 10, or maybe even 14, I don't know, 13. Do you see any? I don't really see any clusters, and I definitely don't. That one's very vague, very not, not a big deal. Okay, so let's move on to this one. Something that will actually have some of these relationships. Take a look. Very last slide. This is a really good example. So we're going to interpret this scatter plot for the men's Olympic 100 freestyle swim winning times. If an association exists, make a conjecture about the winning time. A conjecture, they use that word a lot in math. That just means make a prediction based on your data, all right, about the winning time in the 2016 Olympics. We're going to pretend that the 2016 Olympics hasn't already happened, because remember, this is an older book. We're going to get a new one in 2 years. Okay, so variable association. Is there association between the year and the time? And I hope your answer is yes, because what is happening to the time of the freestyle as the years continue to pass? They are definitely decreasing. So it is a negative, which makes sense. They're getting faster, right? They're getting faster, so their times are getting shorter. Okay, linear association, what do you guys think? Do you think it's a line? I'm going to say yes, linear. That's pretty darn close to a line. I could draw my line of best fit in there, which we will do next lesson. All right, other patterns, I would say there really isn't a cluster, and there really isn't it's pretty good data. There's not really any clusters, and there's not really any outliers. So I would say no other major patterns. And then a prediction for 2016. Now, if you'll see, it's actually going up by 4. So here's 2004. Here would be 12, and here would be 16. So if I looked at my line, a good prediction of time would probably be right around 45 seconds, right? 45 to 46 seconds. Prediction. Okay, and then remember, if we were to make a sentence, write a sentence about this. I know it doesn't ask for one, but they do on your worksheet, so I wanted to make sure we touch base.